My name is Francis Ginger, and today we're going to be learning how to use the law of sines and cosines. Today I'm going to teach what the law of sines and cosines are, how to use the law of sines and cosines, and when to use the law of sines and cosines. By the end of this lesson on how to use the law of sines and cosines, you should know the formulas for both the law of sines and for the law of cosines. You should know how to find an angle measurement given 3 side lengths or 2 side lengths in one angle, and you should be able to find a side length given 2 sides in one angle or 2 angles in one side. Before we begin, there's just a tiny bit of background information we need to cover first, and that is a triangle's angle measurements add up to 180 degrees. So if we are given 2 angles, we are really given 3 because we can solve for the third. The important thing about the law of sines and cosines is that both of them can be used on triangles that are not right, like this one. Well, what is the law of cosines? Well, in word form, the law of cosines is 1 side length squared is equal to the sum of the other squared side lengths minus twice the product of those sides and the cosine of the angle between the two. Now that phrase written as a formula becomes a squared equals b squared plus c squared minus 2bc times cosine of a, and can also be written as b squared equals a squared plus c squared minus 2ac times cosine of b, or c squared equals a squared plus b squared minus 2ab times cosine of c. And these are for a triangle that is labeled like this, with capital A, capital B, capital C as the angles, and lowercase a being across from capital A, lowercase b being across from capital B, and lowercase c being across from capital C, and those represent side lengths. So we know what the law of cosines is, but when can we use it, and what can it be used for? Well, the law of cosines can be used to find the last side given the 2 other side lengths and the angle between the two, known as SAS, or it can be used to find any angle given all 3 sides of the triangle, known as SSS. Okay, now it's time for some examples with the law of cosines. There is my reference triangle, to which I will be plugging in variables and trying to solve for various different sides and angles. I will put the problems up on screen as I do a time lapse of me solving these problems. So we are back, and the first example, the one on the left, is an example where you are given 2 sides and an angle in between the two. The angle was 28 degrees, the side lengths were 4 and 8, and so we just started off, we listed our formula. So we're trying to find side length B, which B is across from angle B, and we have B, A, and C, so we're going to use the formula B squared equals A squared plus C squared minus 2AC times cosine of B. Afterwards, we just plugged in our variables, so A was 4, C was 8, A is 4, C is 8, capital B is 8, or 28, I'm sorry. So B squared equaled 4 squared, which is 16, plus 8 squared, which was 64, minus 2 times 4 times 8, which is also 64, cosine of 28. And so B squared equaled 80 minus 64 cosine of 28. We just added the 2 terms here. Then afterwards, 64 cosine of 28 is approximately 56.51. So B squared equaled 80 minus 56.51. And then B squared is approximately 23.49. And take the square root is B was approximately 4.85. So B would have been 4.85 here. The second example, the one on the right over here, is a SSX example when you are given all 3 sides and we are wanting to find one angle. So, well, we want to find angle A right here, and since we have all 3 sides, we're going to be using the formula A squared plus B squared plus C squared, or no, that's wrong. A squared equals B squared plus C squared minus 2BC cosine of A. Well, I rewrote it so that I could find the value of A easier. So add 2BC cosine of A to both sides, and you subtract A squared to both sides to get 2BC cosine of A equals B squared plus C squared minus a squared. And then afterwards we divided by 2bc to get cosine of a all by itself. So cosine of a equals b squared plus c squared minus a squared over 2bc. Then we took the cosine inverse to find the actual angle. So a ends up equaling the cosine inverse of b squared plus c squared minus a squared over 2bc. And then at this point it's just plugging in the variables. So b equals 11, so 11 squared, c equals 14, so 14 squared, and then a equals 7, so minus 7 squared. And then over 2 times 11 times 14. So a equals the cosine inverse of 11 squared plus 14 squared minus 7 squared over 2 times 11 times 14. So a ends up equaling the cosine inverse of 121 plus 196 minus 49 over 308. Now 121 plus 196 minus 49 is 268. So a equaled the cosine inverse of 268 over 308. And when we plug that into a calculator, the cosine inverse of 268 over 308 is approximately 47.52, which is the measure of angle A. In word form, the law of sines is, in a triangle, the sine of an angle over the length of the side across from it produces the same number for all angles and their corresponding sides. The formula for that phrase is sine of capital A over lowercase a equals sine of capital B over lowercase b equals the sine of capital C over lowercase c in a triangle labeled as such, where capital A, capital B, and capital C are all angles, and across from them are lowercase a, lowercase b, and lowercase c are the side lengths. Now that we know what the law of sines is, when can we use it, and what can we use it for? Well, the law of sines can be used to find the unknown length of a triangle given two angles in one side in a configuration of angle, angle, side, or angle, side, angle, or it can be used to find an angle given two sides in one angle in a configuration of side, side angle, not side, angle, side. Now it is time for examples with law of sines. Just like before, I will be doing problems and time-lapsing them and putting the problems up on screen. The only thing different is that I changed the green SSA to orange just because it'll show up better on the camera. And we are back. So as you can see, I did 3 examples this time. 2 of them were angle, angle, well, 2 angles and a side, and one of them was 2 sides and 1 angle. So the first one, the rightmost one in purple, was a case of angle, angle, side. So our first angle was 28 degrees, our second angle was 11 degrees. We had a side of 17, and we were trying to find side B. So we had this angle, we had this angle, and we had this side, and we wanted to find this side. So what do we do? Well, we wrote our basic law of sines equation. Sine of a over lowercase a, sine of capital B over lowercase b. So cross multiply, you get b sine capital A equals a sine capital B, and then we divide by sine of a because get b by itself. So b equals lowercase a sine of capital B over the sine of a, and now we just plug our numbers in. So b equals 17 sine 11 over sine of 28, and when you put that in your calculator, you get a value of approximately 6.91 for b. So our middle example, the one in blue, was an angle side angle. We had angle B, which was 42 degrees. We had side length A, which is 27, and we had angle C, which was 9 degrees. And we were trying to find this side length here. So what did we do? Well, first off, we had 2 angles, so we could just find the third one, right? So what's that? Well, angle A would be equal to 180 degrees minus the measure of angle B minus the measure of angle C. Okay, we just plug that in. So angle A equals 180 minus 42 minus 9, and that gets you a number of 120. So angle A equals 129 degrees. So now we just have our law of sines equation. Sine of C over C equals sine of A over A. Okay, so now cross multiply, get a sine capital C equals C sine capital A, divide by sine of A to get C by itself. we get C equals A sine of capital C over sine of capital A. Now we just plug our numbers in. Well, A equals 27, capital C is 9, and then lowercase, or capital A is 129. So when you plug that into a calculator, it's 27 sine 9 over sine of 129. And so lowercase c, this side here, equals approximately 5.43. And now the final example, it's a really long example. It was a case where we had this side, and then an angle, and we were trying to solve the last side. And it's a lot of work. I ran out of space, but eventually it becomes one of these two problems once you get the third angle. So start off. Side A was 98, side B was 104, and angle A is 2 degrees. So we're trying to find side C. Okay, well, we want to find one of these angles. So sine of A over A equals sine of B over B. Cross multiply. Or actually this time we're trying to find an angle. So this time we just cross multiply B across, so we get B sine capital A over A equals sine of B. So we then take the sine inverse to get the angle itself. So B equals sine inverse of B sine capital A over A. Now we just plug our numbers in. B equals the sine inverse of 104 sine 2 over 98. When you plug that into your calculator, you get a value of approximately 2.12. Now, just like before, we're trying to find, since we have two angles, we're going to find the third. So angle C equals 180 degrees minus the measure of angle B minus the measure of angle A. So angle C equals 180 minus 2.12, which is angle B, minus 2, which is angle A, which gets you a value of approximately 175.88 degrees. And so at this point, it's just like one of these two problems, and you set it up as sine of C over C equals sine of A over A. I ran out of room, but you cross multiply C, so you get what? A sine C equals C sine A, divide, so that you get C equals A sine C over A, or A sine capital C over A. And then you just plug in your numbers, so what? Lowercase c would equal, not that one, that's 2. Oh, A would equal 98 sine 2, no, 98 sine 175.88 over 2, sine of 2. And that gets you your C value, which is approximately 201.75. Alright, so it is word problem time. I'm not going to write the word problem down. I'm just going to put it up on screen during the time lapse of me doing this problem. But it's going to use elements of what we have learned today of law of cosine and law of sine. So enjoy. Alright, so this was the word problem. It, tricky enough. The only part of it that was problematic was trying to find angle B off of the instructions for the word problem. But other than that, it was relatively okay. So the word problem was, Andy lives on Route 2. Andy wants to know how far away from his work he lives. To get to his work, Andy travels on Route 2 for 8 miles before getting onto Interstate 293. He then travels on Interstate 293 for 43 miles. The exit from Route 2 to Interstate 293 is a 54 degrees counterclockwise turn. Ignore the distances spent on the exit, and then also solve for the triangle. So, to find angle B, we had to, I told you it was a 54 degrees counterclockwise, so it was 180, he was going straight first, and then he went 54 degrees this way, which 180 minus 54 was 126, which is where that came from. And so then we were trying to find, originally, the distance from Andy's house to his work at point C. So this is the law of cosines. B squared plus a equals a squared plus c squared minus 2ac cosine of b. Just plug our numbers in, pretty straightforward. B squared equals 43 squared plus 8 squared minus 2 times 43 times 8 times cosine of 126. So b squared ended up equaling 1,849 plus 64 minus 688 cosine of 126. Add like numbers. So b squared equals 1,913 minus 688 cosine of 126. Cosine of 126 equals negative 404.4 approximately. So just switch it out. So b squared equaled 1,913 minus negative 404.4. So b squared ended up equaling approximately 2,317.4. You take the square root, and b equals approximately 48.12 miles. That was b, the distance from Andy's house to his work. And I also said solve for the triangle. So now we have to solve for angle C and for angle A. Now we already have one angle and we have all of our sides, so we just have to use the law of sines. So sine A over A equals sine B over B. And so sine A, cross multiply, actually just the A because we're trying to find an angle. So sine A equals A sine B over B. And then sine inverse. So A equals the sine inverse of A sine B over B. Now we just substitute. A equals sine inverse of 43 sine 126 over 48.12. So A ended up equaling approximately 46.3 degrees after you plug that phrase into your calculator. And now we just have to solve for the last angle C, which all of the angles in a triangle add up to 180. So we just take angle C equals 180 minus the measure of angle B minus the measure of angle A. Substitute in. Measure of angle C equals 180 minus 126, the measure of angle B, minus 46.3, the measure of angle A. And then angle C ends up equaling 7.7. So just some additional details before we finish. Like, one question you might have had is, well, how do we check our answers so that we know that they're right? Well, you can use the law of sines and the law of cosines to check one another and plug your variables into the law of cosines and also the law of sines. And if you get the same answer for both of them, then your answer is correct. And then there are some real world, like, what are the real world applications of this? Well, for one, you can triangulate the position like GPS or satellites or cell towers. Two, you find the distance between 2 points in, I don't know, like we did in a word problem, like points on a map, or 2 points like your house and work, whatever, 2 points. And finally, you can also calculate angles when designing buildings. That way you can know if, hey, this angle will work or this angle won't work because this is the distances we have, or we can't use this angle because it's not good and the structure will collapse. But there are many more applications. These are just a few of them. So real quickly, we're going to wrap up everything we have learned today. So today we learned what the law of sines and cosines are. We learned when and how to use the law of sines and cosines. And we learned why using the law of sines and cosines might be useful in everyday life. That's all for today. Join us next time. We're going to be doing basic matrix operations. Woohoo!